We're glad y'all are here. Our last speaker, Emily Freeman. So, you know how they always say that, what was that? Emily Freeman. There's her whoop. All right. You know, there's always that, they were in the trenches. Emily wasn't in the trench, she dug the trench. She's been at AWS, Microsoft, Kickbox. Somehow is a psycho and now has her own company. I don't know what you're thinking. She is something else. She's also an author. So co-authored, what was it, DevOps for Dummies? You did do that one by yourself. All right, best-selling author, DevOps for Dummies. You know, y'all got on your thing. And then I love the title of this one, 97 Things Every Cloud Engineer Should Know, which sounds like a threat and a compliment all rolled up in one. She's going to go over the most entertaining talk you've ever had on incident response, which is a very low bar, but she's going to blow it away. Emily, come on.
Tech was not a passion of mine from a young age. I never played video games. I wasn't particularly passionate about computers. I went to school for politics. That was my first true love, not engineering. I wanted to live in this Aaron Sorkin White House, right? Where people considered hard things with passion and empathy and unnecessarily overly complicated soliloquies with elevated vocabularies. Like all humanities nerds, I love words and history and humans. 10 years ago, I had my daughter, Clara. She is magnificent and precocious, this amazing combination of confidence and chaos. But 10 years ago, I sat on a sidewalk in DC, where I'm from. I was holding Clara. She was only a couple weeks old. It was still cold, but right on that edge between winter and spring. The sun hit my skin, and I sobbed. Not the cute cry when you're having a bad day. I mean truly breakdown on that sidewalk. At the time, I was a ghostwriter, and I had this little business called Editing Emily. But for 1,000 different reasons, I knew at that moment that my marriage wasn't going to survive. And although I was proud that I had built something from nothing with my little writing business, I did not make a ton of money. Most writers rarely do. In that moment, I realized that I couldn't support my daughter and I in DC independently on a writer's income. And so, in my stupor of postpartum hormones and my slightly older than quarter life crisis, and a little bit of just pure fear, I realized that I needed to switch careers. Frankly, I needed to make more money. I knew that software engineers made pretty good salaries. And somehow, through sheer hubris, I thought, well, how hard can it actually be? Turns out moderately hard. But I'm so happy that in that moment of uncharacteristic confidence in my ability to learn, because although I started in tech for the income, I could not have landed in a more remarkable community. So, to switch careers, I packed myself up and I moved from my home in DC to Denver, here, my new hometown. My daughter was 6 months old when I started code school, and for 7 months, I learned how to code in Ruby. When I graduated, I took a job in Java, which was, I knew you were gonna love that. It was another shock to the system. The Ruby to Java cliff is not one I'd personally recommend, but I survived and I thrived. And it was at my first job that I stumbled onto DevOps, or rather the opposite of DevOps. It was a very traditional engineering team, if you can even call it a team. Extremely siloed. There was only one ops dude, of course it was a dude, and he was not a happy human at all. Developers had zero access to literally anything in the infrastructure. I couldn't even read logs, which perhaps unsurprisingly caused a lot of friction. And so at some point, there was a bug I was supposed to fix, there was a fight, I got very frustrated, and I went into this break room and I sort of angry typed in abstract, Humpty Dumpty, a story of DevOps gone wrong. And that kicked off, well, most of my tech career. I'm Emily Freeman. As they said, I'm the author of DevOps for Dummies and 97 Things Every Cloud Engineer Should Know. I'm the CEO and co-founder of Freeman Forrest, the first influencer marketing company focused purely on B2B tech. And prior to that, I was at AWS and Microsoft. I love DevOps because it is this acknowledgement that we as developers are part of a socio-technical system. And our extremely human impact, both the magnificent parts and the terrible parts, are on full display during incidents. It's like speedrunning failure while everyone watches you struggle and your boss, theoretically burns money in front of you, no pressure. Then often there's a review at the end of it, what we now call a post-incident review, but previously a post-mortem. I like incidents as examples because it's one of the areas in tech where we can actually pull a ton of knowledge from outside of tech. The truth is, fires are never going to stop. You can throw as much money and as much AI into the system as you want, but we are flawed, and our systems reflect those flaws. There will always be mistakes and errors and outliers. And even if we were perfect, our systems are so dependent on other tools that it would be impossible to remove those dependency failures. If you're a GCP user, you just survived the outage in June due to an identity and access management, IAM outage. Last year, Cloudflare had a major service disruption in June. June is apparently a very rough month for everyone. And in fintech, the stakes are even higher. We deal with people's money. And if there's one thing people get real persnickety about, it's their money. We are expected to be perfect. And I'll tell you right now, when my bank's mobile app isn't working or is unavailable, well, I get a level of panic that I just don't when Netflix is being a little bumpy. There's an intense pressure for your work to be flawless. But that is just not realistic. So how do you respond when things go awry? I like focusing on incident response versus incident management. You'll hear both. But to me, incident management feels like a situation you come across, you deal with, and then you forget about. You managed it. It's done. But incident response, that's something that has an extensively long history. Firefighting, the kind with flames, was created as a lucrative scheme in ancient Rome by Marcus Licinius Crassus. Only we would not have considered his brigade heroes. They would arrive to the fire and do nothing, while one firefighter negotiated a price with the homeowner. And if an agreement could not be reached, they would let it burn to the ground and then renegotiate at a much lower price. This is not a strategy. Don't take that to VCs. This is not something we want to emulate. Firefighters have clear procedures and a really strong hierarchy. The first truck at a scene immediately begins assessing the situation. They evaluate building construction, visible smoke, fire, and flow paths. The incident commander, there's always one, gives orders to their personnel regarding fire attack, as well as calling for additional resources, communicating with those not at the scene, and preparing an action plan, which sounds a lot like a tight, orderly process, because it is. Firefighting has actually come a really, really long way. And I'm not talking about way back in Rome. I'm talking about 50 years ago. And if firefighting, something that is rife with military-like regulations, can advance quickly and methodically, surely we can, because that's what we do best, right? Iterate quickly to engineer the best solution. The 70s, when you think of them, you might consider disco and bell-bottoms, and polyester wasn't necessarily fashion's greatest decade, but it also saw a ton of political upheaval. The Cold War was in full swing. Much of the Middle East was warring with Israel. Some of this might feel familiar. And the US began winding down their presence in Vietnam. But buried deep in all of that political chaos, there is a series of destructive fires in California. So destructive and deadly that firefighters were forced to rethink their approach. So they went to the state. And those folks did what any bureaucrat would. They had a meeting. And then they formed a task force. And because a government agency has never met an acronym it didn't love, it became the task force that was Firefighting Resources for California Organized for Potential Emergencies, or FireScope. The findings were actually really interesting. An organization must be flexible to respond to the needs of various incidents. No two incidents are the same. They might be similar in the same neighborhood, but they're not the same, and we have to be prepared for that. We have to use consistent systems and platforms. The folks in FireScope realized that using one communication plan for forest fires and another system for house fires didn't make any sense. The more you use a particular system, the more it becomes second nature. It embeds itself into your muscle memory. Standardize everything and make it easy to understand. Firefighting systems and processes must be standard enough that when needed, a firefighter from Northern California can assist a house in Harlem. Keep the price low. Budget always matters. None of us have unlimited budget unless you're an AI startup. And we must find solutions within those constraints, within our particular teams and organizations. I would argue sometimes that means getting really creative, and sometimes those constraints make us more creative. The processes put in place by FireScope, they worked. They saved lives. And for decades, that is all we needed. And then 9/11 happened. And it became woefully apparent that we as a nation were not prepared to meet a crisis of that magnitude. FireScope evolved into NIMS, the National Incident Management System. It standardized resources, processes, and terminology across all emergency response organizations. I don't have time to dive into NIMS all the way, but if you're interested in this type of thing, it's worth a read. My favorite part of NIMS is that they normalized or standardized terminology. I think this is something we could really stand to learn. Because language matters. More than that, the stories we tell matter. When we don't have a shared framework, some scaffolding on which to put things, we are forever limited by how we can adapt to each other and improve independently. We can take a lot of inspiration from emergency services and their approach to incident response, and we should, because they work at scale. They're already proven. But that's not the entire story, is it? I mean, a software incident isn't a fire or a hurricane. It may feel like that. It can certainly give you an adrenaline response. But when talking about this topic, I like the word response over management also because for me, it reflects this repetitive nature of these incidents. We're always going to have them. They are part of our daily existence. For me, it's not about trying to eliminate incidents. It's about making them smaller, more expected tasks, even standard parts of your workday. And that requires a really unique approach to architecture, development, and operating. I want to take a minute, step back from this topic, and discuss how we communicate as an industry. I think between social media and the algorithms and AI, our attention spans have been whittled down to near zero. I'm in this picture too. I love Instagram. And this has damaged our tolerance of nuance. In social media, there's something called context collapse. The term was coined by Dana Boyd. You know I love a social scientist. Context collapse is the flattening of multiple audiences into a single context. What does that exactly mean? Well, you and your friends have a shared context formed over time throughout your friendship. If you have coworkers and colleagues, you have that shared context of your workplace, those unique institutional customs and knowledge. Words are powerful. That's why I love them. But words are not enough. I am continuously frustrated by the limitation of my own rather verbose spoken language. We lack words that would convey deep meaning in specific contexts. They just don't exist yet, at least not in every language. And I think it's these gaps that contribute a lot to conflict and misunderstandings. But words are our only real medium with which to convey complex thoughts and ideas and feelings to each other. As you move away from those in-groups of shared context, your friends, your colleagues, your peers, we begin to enter groups with which we have no reputation, no trust, no mutual understanding. This impacts how we communicate with each other in every medium, including in person. I define community as the places people gather to share experiences, learn, socialize. We have a lot of communities in tech. We're very lucky, and there's a ton of overlap. You likely belong to many communities within our broader industry. But there's been this flattening of advice, dare I say thought leadership, that's been reduced to little quips, funny retorts. It's increasingly worse as the voices we listen to become consolidated and the topics we talk about, yes, AI, become limited. I think we're better than that. I think we're some of the smartest people on the planet, and we are capable of gathering together, thinking critically about a concept, even if we don't immediately agree. We're capable of sitting with that and working through the nuance, ruminating on the good, the bad, the weird, the undefined, having our own Aaron Sorkin moment. I think we are capable of having much more complex discussions than we are currently having. And I think there's this over-indexing right now on taking the advice of others and implementing those ideas, rather than feeling inspired by them and then making them right for our unique circumstances. You see this right now across a number of areas in tech, including DevOps. Somewhere along the line, we really lost our focus on reducing silos and building bridges, and instead began to focus more and more into individuals. One of the unintended consequences of DevOps has been this pressure or belief that everyone has to do everything. That a JavaScript developer has to understand the intricacies of a CI/CD pipeline or the details of your cloud infrastructure. And on the other side of the coin, there's been this emphasis on developers lately that has left other folks feeling ignored, maybe unsure of their role. And all of this is being thrown out the window. We're facing conversations about how computer science may not matter anymore, has no relevance, that AI will replace software engineers. I don't think that could be true. I think it's not close to what the actual future looks like. But we need to own our decisions and be accountable to our work. Go back to the basics and proceed with confidence with what we're doing, knowing that our expertise is not useless, not in the slightest. Before we had DevOps, we had something a little like this. There was no overlap. Developers would write code and with zero concern for anything beyond that code, nothing about security or testing or operations. It was glorious. They would type into their machines, and once the program compiled, it was someone else's problem. It caused a lot of frustrations, as you probably know. We lived this. The first name for DevOps, I love it, was Agile Systems Administration. In other words, how do you take those agile principles and apply them to infrastructure or operations? And I believe the intention of DevOps was actually something like this. It's overlap, communication, shared processes. This is an awareness of the complexities and concerns of your colleagues in different roles. This is collaboration and teamwork. It makes me happy. But somehow we ended up here. And y'all, if I contributed to this, I'm sorry, because this is not the answer at all. It's like we overlaid the SDLC with developers and said, ship it, it'll be fine. That lack of nuance in messaging, the compression of ideas and thoughts and methodologies, it all led us here. And this problem is deeply integrated with incident response. It is really important that people have ownership and accountability over the services they build. I agree with that. But creating an organization where, following the interpretation of DevOps, that says developers are responsible for their own code the entire life cycle, well, I have just never seen that be very successful at scale. Not only because it eliminates or demoralizes specialty groups outside of development, because at some point, developers, you're asking them to be an expert in a stack of languages, an expert in security, different tools, testing, deploying, releasing code, operations, infrastructure, and an expert in identifying and responding to incidents. I don't know about you, I'm not a superhuman. I feel overwhelmed just thinking about trying to be an expert in a handful of things, let alone a dozen. It's not possible. I'm guessing I'm not alone in this. In fact, I'm guessing some of you feel pretty ill-equipped to ship software in this new world that is resilient to failure and respond to those incidents that come up, and to do this more quickly than ever before. And as much as we want to rely on AI, I don't think it's going to fix this in the next year, maybe not in the next 5 years, maybe not ever. I think for the foreseeable future, for all the benefits of AI, and there are real actionable benefits. I am not anti-AI. But it is just as likely to inject chaos and trash into your brownfield systems than it is to streamline your work. On top of all of that, I think developers and engineers of all kinds do their best work when they feel empowered and fulfilled, even happy. To achieve this, I think we have to take a step forward and think about what's next. How do organizations not only apply DevOps in a way that increases velocity, but design their teams and socio-technical systems for resiliency? And this requires us to look at the full software delivery process. Because I would say incident response isn't just about getting better at responding to incidents. It's not that isolated. It's about reducing the quantity, severity, and scope of those incidents. Like children, our applications grow and change in ways that are both horrifying and delightful because we are at the will of a force we cannot control, the customer. They do things we don't expect. So how do we proceed? Well, if you're anything like me, you have moments where you doubt yourself, questioning your talent, your purpose, even the value of your impact. It's so much easier to become paralyzed by fear and uncertainty. If we can't proceed or know how to proceed, how do we keep moving forward? I believe the first step is really in accepting that modern software development, there's no beginning and no end. We are in a constant state of motion. And part of that shift is eschewing the old way of thinking about our work. A few years ago, I pitched a radical new idea, a replacement for the SDLC. Now, if you're familiar with the software or systems development lifecycle, what we call the SDLC, it looks something like this. And I was shocked to find out that this has been in use since the 1960s. The SDLC is a boomer. And over all these years, it has remained more or less the same. There's always slight adjustments. We've added steps in. There's variations. Certainly with DevOps, we had the DevOps toolchain, and we kind of twisted that into an infinity loop. But beyond being linear and unreflective of our daily work, I think the biggest issue with the SDLC is that it has become an assumption. We don't even think about it anymore. And if you don't believe me, let me show you. When DevSecOps became the first derivative of DevOps, there were many, it sought to move security left. This should show you the pervasiveness of the SDLC. a phrase meant to bring awareness and consideration of security earlier on in the process, relied on this framework, this reference to the construct. I think assumptions limit us. I think they already make a difficult task of communicating even more difficult. The models we use and the ways we discuss our work impact our work. I think we need a model capable of capturing this multi-threaded, non-sequential nature of what we do, as well as embody the roles engineers take on and the considerations they have to think about along the way. When I was thinking about this, I was inspired by ideas like extreme programming and the spiral model. I wanted something that would build on the foundations of Agile and DevOps and represent this iterative nature of continuous innovation. What I settled on, I call the revolution model. And I believe this visualization is capable of capturing the pivotal moments of any software scenario. I call it revolution because, for one, it revolves, at least in theory. Its circular shape reflects the continuous and iterative nature of our work. But also because it is revolutionary. I am challenging a 60-year-old model that is embedded into our daily language. The model is constructed of 5 concentric rings. You have architecting, developing, automating, deploying, and operating, our roles. Intersecting each loop are 6 spokes that describe the production considerations every engineer must consider throughout any engineering work: testability, securability, reliability, observability, flexibility, and scalability. The considerations listed are not all-encompassing. There are, of course, things that I left out. But I figured if I made 20 spokes, we all might have a problem. So let's dive a little deeper. The circles that create the base of the model are really about our roles as engineers and a shift in thinking about that. We have long used personas as the default way to divide audiences and to group people. Personas bother me. I don't like them. Because they're either an oversimplification of someone's work and role, or they sort of needlessly complicate that person's work. Few people fit really cleanly and completely into persona-based buckets anymore, like developers and operations. The lines have gotten really fuzzy. On the other hand, I don't think we need to tailor messages so specifically to call out the difference between similar roles. But perhaps most critically, I actually believe personas are immutable. A persona is wholly dependent on how someone identifies themselves. It's intrinsic, not extrinsic. Our titles and our jobs change relatively frequently. But we likely still consider ourselves part of a single persona: a programmer, a developer, database admin, IT pro, security engineer. I was a developer. I am always going to identify as a developer. My background influences not only how I see myself, but also how I approach my work. Roles are very different. Roles are temporary, inconsistent, and constantly fluctuating. Your work isn't confined to a single set of skills. It may have been a decade ago, but not today. And beyond all of this is a perhaps more important concept, that we're not just devs or ops anymore. We play all these roles at different times. And no, I'm not quite ready to add vibe coder to the list. AI is a tool, not a person. And it's not a replacement for you. It is, if utilized well, an acceleration of you, an augmentation. AI, like every invention before it, is moving us up the stack. It is an abstraction that enables us to automate the mundane, to optimize our time, and to specialize in the areas unique and relevant to our various businesses. No matter what role we play, we have to consider a number of issues. The first is testability. All software systems require testing to assure architects that designs work, developers that code works, operators that infrastructure is running as expected, and engineers of all types. that code changes won't bring down the system. Testing, in its many forms, is what enables systems to be durable and have longevity. Security is everyone's responsibility, but few understand how to design and execute secure systems. I struggle with this. I think security is something we know we should all dedicate time to, but struggle to make time for. And let's be honest, it's hard and complicated, and the consequences are really scary. It is absolutely critical that applications and services work as expected most of the time. That said, availability is often mistakenly treated as a synonym for reliability. But instead, it's a single aspect of the concept. If a system is available, but customer data is inaccurate or out of sync, the system is not reliable. Reliability may be the end result, but resiliency for me is the journey, the action engineers can take to improve reliability. Observability is this ability to have insight into an application or system. It's telemetry, monitoring, alerting. There's an aspect of observability that overlaps with reliability. But the purpose of observability isn't just to maintain a reliable system. The concept originates in linear dynamics and is defined by how well the internal states of a system can be understood based on information about its external outputs. Observability is more about understanding than anything else. Flexible systems absorb new code smoothly, embody a clean separation of concerns, and are partitioned into small components or classes. These are the fundamentals. Flexible systems are architected to enable the now and the next. In our work, the only constant is change. In every role we play, creating flexible solutions that will grow as the application grows is critical. Scalability refers more to the system's ability to actually grow over time than just scale with additional load. It implies growth, an ability to absorb and grow. Scalability in this model really carries the continuous innovation of a team and the byproducts of that growth within a system. For me, it is the most human of all the considerations. It requires each of us in our various roles to consider everyone around us. The customers who use our system and rely on its services, our colleagues, current and future, with whom we collaborate, and even our future selves. We have to read that code too. One of the reasons I'm so passionate about this model is that it democratizes accountability. Accountability can have a massive impact on incident response. I prefer the word accountable over responsible because it's a willingness to account for one's actions, whereas responsibility is having control over a situation or a duty to deal with an issue. The best example I have of this is parenting. As a mom, I am responsible for keeping my child alive and providing basic necessities, food, shelter, clothing, etc. But the higher order role I have is to love her, to model the principles I value, and to train her to be a self-sufficient, independent, functioning human. And that's where I am accountable to her. Because I make decisions daily, and I never know if I'm choosing correctly, but I do know the information I had at the time, what I used to make that decision, and how I came to that conclusion. And when she's older, I'll be able to account for my decisions. Because even in the cases where I'll have chosen poorly, I have the confidence that I made the best choice I could given the information I had at the time, and that is all we can do. I want to repeat that because I think universally we're all under a lot of pressure right now. And I want to tell you that looking back with hindsight or criticizing from the sidelines, that's easy. Criticizing, very easy. Doing the work, that's fucking hard. And if you show up every day and make good decisions with the information you have, you're killing it. Don't think for a second that you're not good enough. You're doing great. The model many of us are currently working in puts all the responsibility into a single role. And I want to back out of that. I want to embrace this accountability. And I believe that Revolution can help redirect us from this developer-centric interpretation of DevOps to an implementation that enables flexibility, respect, shared accountability, and understanding. The model calls out specific specialties and areas of domain expertise. And this is important because these areas will always be critical to our shared success. Not in a way that means a single role carries the weight of the entire system or even a sliver of that system. It rejects this notion that experts who do not identify as developers are second-class citizens. It is a culture where everyone stands on equal ground and has visibility into the work of others. This creates a culture where teams can respond to incidents rather than react to downtime. So let's look at how this might work in practice. Take something like testability. A developer, at a minimum, is responsible for unit tests to verify the behavior of the features they're building out or the bugs they fix. I'd argue there should be additional tests, but that's a different talk. Angie might give it as well. Anyone working to automate processes and remove the manual toil should be automating tests. These tests run every time code is committed to the main branch. And any continuous integration or deployment pipeline should absolutely have integration tests or end-to-end tests implemented. These are just a few of the intersections you can start to see between roles and considerations. And the important part, you can measure this. Now, in this case, the metric of test coverage is flawed. And it's probably going to get worse because, in my opinion, AI is verbose. We see this. And it's probably going to inject a lot more lines of code. I am personally concerned about relying on AI for testing without strong verification in place. But my anxiety aside, test coverage is a way of noting the testability of a system, a service, a class. And don't forget about qualitative data, too. Engineer opinions are data as well. I think sometimes we think only about data being quantitative, and that is valuable. But the opinions of experts can be just as valuable. And this is just one example. You can utilize this model as a way of measuring a baseline and reevaluating progress at set intervals. You know the data you have available to you, where you have gaps. Utilize the data where available and fill in those gaps with qualitative data. Even an assumption at the beginning is a better anchor than nothing when attempting to establish a baseline. Each of these areas impact incident response. This model normalizes work in a way that the SDLC never did, because our work is never finished. I'll be honest, I struggle with housework. I'm a bit of a mess. My house is, quote, lived in. It's my favorite comment. One of the reasons my home is untidy is because I'm not diligent about regular cleaning. It turns out people that always have clean homes tidy constantly. They put things away every time. They do the dishes every night. They clean constantly. I don't understand it. But it is this diligence, this regular attention that creates a clean space. I think our work is really similar to this. There's no finishing something and then moving on. Everything we build must be maintained. Nothing in our systems is completed. Instead, like laundry, it is just in a state of a constant cycle. Every piece of code must be updated, deleted, and it's this regular attention that holds the key to better incident response. Because it isn't about avoiding those incidents, it's about making them a part of our regular work. There are generally 5 levels of incident severity. If you want more details than I can give in the next 5 minutes, I still recommend PagerDuty's incident response information. It is some of the best in the industry. It's great. Sev 1 is the most grave type of incident. Functionality is severely impacted, and large amounts of customers can't use the product. These incidents carry the risk of violating SLAs or service level agreements and typically require public statements to address the issue. They're embarrassing, and they ruin everyone's day. Sev 2 is a severe product or service degradation that impacts a large number of customers. Sev 3 can escalate to Sev 2 pretty quickly if it's not responded to immediately, but they typically impact a smaller group of customers or involve a single service. Sev 4 incidents don't generally affect a customer's ability to utilize a product. Maybe it's slow, there's performance issues, and finally, Sev 5 are really bugs. Customers notice something odd, but they can still utilize the product. The feature functionality is there, generally as expected. There is a distinct bifurcation between the first two severity categories and the latter three. Sev 1 and Sev 2 incidents are major disruptions. They cause and require immediate and large-scale responses. The others are easier, or at least more simple to address. We're never going to eliminate these incidents. There will always be issues and bugs and performance problems and outages. But we need to start treating incidents like normal work. And that requires fewer of those Sev 1 and Sev 2 incidents. In the major ones, you have no choice but to react. Stress is high, it distracts from ongoing proactive work, it creates technical debt, and it exhausts engineers. The more these severe incidents occur, the more people begin to feel like their job is a series of Sisyphean tasks. And this is where we have to take those methods from emergency responders and apply them to our work. We need an incident commander, we need a response plan, and shared language for how to respond. But that should not be the default. Instead, we want boring tickets that get moved to the top of the priority list. And to accomplish that, it is less about actual incident response and more about planned small improvements measured over time. The shared accountability model of this revolution model acknowledges that there's no beginning and no end in software development. Not anymore. Incident response isn't a perfect line with a beginning and an end. It is continuous, diligent work. I believe this model, while not perfect, gets us closer to this next phase of DevOps, where I hope we're all headed. It captures this ever-changing complexity of our socio-technical systems, and it emphasizes workflows and processes that make the right thing to do the easy thing to do. Incident response starts with shared accountability, and that goes beyond our standard work. It starts with us. Your voice is powerful. Your ideas are novel. You've had days to listen and learn, and when you go back to work, share with your colleagues, your friends, your peers, your community. We need a modern model, a modern approach for a modern era. And I believe this is just the revolution to get us started. Thank you so much.